Hey, Bruce. How are you doing?
Hey there.
How are you?
So, Bruce, I don't know if you can see us. I'm not sure if we're feeding a camera feed.
You are not.
Right. You're about to get a camera feed of the audience so you can see the community. Thanks for dialing in. You did so last year, and the network gods did not obey. But hopefully, we got a crystal clear connection from you.
Okay, take it away.
All right. Thanks for hang on, let me find my there it is. Find my timer. Oh, there's everybody. God, it's nice to see you all.
Yeah,
right,
we're waving at you.
I want to talk about all right.
Okay. We see you.
All right. I see you. All right. So I want to talk about trust and integrity, which is what I've been thinking about with AI for the past couple of years. Trust is a complicated concept. It's a singular word with many different meanings. So there is a personal, intimate trust. When we say that we trust a friend, it's less about their specific actions and more about them as a person, right? A reliance they'll behave in a trustworthy manner. So I call that interpersonal trust. So there's also a less intimate, less personal kind of trust. We might not know someone personally or know their motivations. We can still trust their behavior. This type of trust is more about reliability and predictability, and we'll call this social trust, right? The ability to trust strangers. So both of these, interpersonal trust and social trust, are essential in society, but they're very different, right? Interpersonal trust is person to person, based on human connection. Social trust involves systems that compel us to act trustworthy, right? I mean, taxi driver used to be one of the country's most dangerous professions, but Uber changed that. I don't know my Uber driver, but the rules and the technology let us both be confident that neither of us will cheat or attack each other. Right? Money is handled by the system. We're both under constant surveillance, and we're competing for star rankings. Right? That's social trust. So because of how large and complex society has become, we've replaced many of the rituals and behaviors of interpersonal trust with security mechanisms that enforce reliability and predictability, right? Social trust. You used to, in the 1950s, need a personal relationship with a banker to get a loan. And now it's done all algorithmically. You have many more options, even though it's much less personal. Right? But because we use the same word for both, we regularly confuse them. And when we do that, we're making a category error. And we do that all the time with governments, with organizations, with systems of all kinds, and especially with corporations. We might think of them as friends when they're actually services. And we're making this category error with AI as well. We're thinking of them as friends when they're not. And there's an interesting through line from governments to corporations to AI. So science fiction writer Charlie Stross, he calls corporations slow AI, right? They're profit maximizing machines. And the most successful ones do whatever they can to achieve their singular goal. Right? The paperclip maximizer is every startup's business plan. David Runciman, he makes this point much more fully in a really good book called The Handover. And he describes governments, corporations, and AIs together as superhuman machines more powerful than individual components. Ted Chiang, another science fiction writer, he says that our fears of AI are basically misplaced fears of capitalism. So we use internet services as if they're our agents, right, working on our behalf. You think of Google or any of the social networks. In fact, we know that they are often double agents, often working for their corporate owners, right? We trust them, but they're not trustworthy. They're not friends, they're services. So this is going to be the same with AI. And we're seeing it today. But I think the result's going to be worse for three reasons. The first is that these AI systems will be more relational, right? We converse with them using natural language. And as such, we naturally ascribe human-like characteristics to them. We have emotional connections with these others. And that relational nature makes it easier for the double agents to do their work, right? Did your chatbot recommend a particular airline or hotel because it's the best deal for you? Because the AI company got a kickback in the back end. Right? We know that OpenAI has said they want to figure out how to integrate advertising into chat. Google, of course, are going to do the same thing. But the conversational interface helps the AI hide its agenda. The second reason is power. Right? Sometimes we have no choice but to trust someone or something because they're more powerful. Maybe more precise, we have no choice but to entrust ourselves to them. I think we'll be in the same position with AI in many cases. Right? We're going to have no choice but to entrust ourselves to the decision making. It'll be AI, not that we choose to use, but it's going to be thrust upon us by people and groups more powerful than us. The third reason to be concerned is these AIs will be much more intimate. AI agents are here, acting as advocates to others and assistant to us. And doing this right requires a greater intimacy than our search engine or email provider or cloud storage system or phone. Right? We're going to want these agents with us 24/7, training on everything we do so it can most effectively work on our behalf. And we will default to thinking of it as a friend, and we're going to want to trust it. But, we don't know if it's going to be trustworthy. So, right, this is all a long-winded way of saying that we need trustworthy AI, where we understand its behavior, its limitations, its training, its biases, its values and goals, and we know that it works on our interest and won't betray our trust to someone else, right? That it's secure against hacking, so it actually does what it promises to do. Right? Remember that social trust is all about reliability and predictability, and that we create social trust through both technologies and laws. And here we need both, because the failures come from two different places, right? The powerful corporations controlling the AIs, I talked about that, and also from others manipulating AIs, right? The cybersecurity of AI. Almost all AI systems are going to be used in some sort of adversarial environment. And by this, I mean that someone will have a vested interest in what the AI produces or the data it uses. Right? So let's imagine an AI as an advisor in some government trade negotiation, or as a political strategist or a legal researcher. Right? There's going to be an incentive for someone to hack that AI, maybe a criminal, maybe a government. And it doesn't matter how accurate or capable or hallucination-free the AI system is, if you can't guarantee it hasn't been hacked, you can't trust it. Right? At the end of the day, AIs are just computer programs, right? Written in software, run on hardware, attached to networks, interacting with users. Everything we know about cybersecurity applies to AI systems, along with all the additional AI-specific vulnerabilities like prompt injection. But people are using and trusting these systems, even though they're not trustworthy. And I think that's going to be a huge issue in the next few months and years. Right? Trustworthy AI requires AI security. And that's a hard technical problem because of the way these systems evolve, right? I mean, how they work. So if you've taken a cybersecurity class, you've learned about the CIA Triad, right? Confidentiality, integrity, and availability, the three properties I'm supposed to provide. Now, we've built decades of security around confidentiality and availability. We've gotten really good at both, right? We're not done, but we know how to deal with those problems. Integrity has kind of been the long neglected middle child. Right? Traditionally, integrity means preventing improper information modification or destruction. But I don't think that's broad enough for what we're building here. I want to think about integrity much more generally. Accuracy. Is the output correct? Completeness. Is anything relevant missing? Consistency, right? Does the meaning drift as data moves, right, in both time and space? Freshness. Is it current or is it replayed or stale? Right? Provenance. Where did the data come from? What touched it? What transformed it? Semantics. Did the meaning change as data moved from formats and models and organizations? Accountability. Can we reconstruct what happened and why? And finally, recoverability. right? When integrity fails, can we detect it? Can we quantify the damage? Can we recover to a known good state? I mean, I think of integrity generally as correctness. And that's, if you think about it, not just one control. It's a sort of an overall system property. Right? Correctness is not a single value. There's no correct way to drive a car. Right? It's an envelope of constraints, invariance, acceptable risk. And integrity is how you keep the system inside the envelope, how you prove it stayed there, even under attack or error or drift. Or maybe, I don't know, I think of it this way: integrity turns information into evidence. Right? Integrity makes IT systems trustworthy. And if you think about it, most attacks against AI systems are integrity attacks. Right? Putting small stickers on road signs to fool self-driving cars is an integrity attack. Prompt injection is an integrity attack. Right? In both cases, the AI model can't distinguish between legitimate data and malicious commands. So manipulations of the training data, the model, the input, the output, the feedback are all integrity attacks. And this is becoming important because the internet is changing, I guess, again, right? In the emerging world, call it Web 3.0, the big shift is agency. Computers increasingly have right access to the world, right? And the internet shifts from an information medium to a control plane for society. Right? IoT devices bring autonomy to more aspects of our lives, and AI agents accelerate this. Right? They don't just advise, but they act. So think of this as the automation of consequences. At machine speed, too fast for oversight. So in this, right, in this smart, distributed, connected, autonomous world, integrity becomes the foundation of everything. Right? Sensors go from data sources to attack surfaces. Right? Anything that's input can be attacked. Then actuators go from outputs to attack capabilities. Anything that can be touched can be weaponized. And in this world of Internet of Things, of AI agents, without integrity, you get the wrong dosage, the wrong valve position, the wrong braking distance, the wrong grid response. Right? In this world, the lines between safety, reliability, and cybersecurity start to blur. So think of all this in terms of the evolution of the internet. Web 1.0, early 90s, early 2000s, was all about availability. Individuals, organizations rushing to digitize their content. This created the vast repository of human knowledge that we call, the web, but making information available overshadowed all other concerns. Web 2.0, right, mid-2000s to now, emphasizes confidentiality. This is the read-write web, where your private data needs to remain private. Online banking, e-commerce, social media, any way you're a participant. Confidentiality was the thing that mattered. Web 3.0, the distributed, decentralized, intelligent web of tomorrow, right, peer-to-peer social networking, distributed data ownership and storage, Internet of Things, AI agents. All of these things require verifiable, trustworthy data and compute, right? Integrity. There's no drone coordination without integrity, or smart power grid, or reliable mesh networking, or useful AI agents. So integrity is the key security problem of this era. And, I think about this in another context. I talked about this as a research question that rivals the internet itself. The internet was created really to answer this question. Can we build a reliable network out of unreliable parts in an unreliable world? Right? That was an availability question. And the answer was yes. Maybe a decade ago, I asked a similar question. Can we build a secure network out of insecure parts in an insecure world? And I meant that as a confidentiality question. So I want to ask this about integrity, right? Can we build a system with integrity out of non-integrous parts in a non-integrous world? The answer isn't obviously yes, but it's not obviously no either. So I've been positioning this as a call to research into verifiable sensors, auditable system outputs, integrity verification systems, integrity breach detection, in ways to test and measure the integrity of a system, in ways to recover from an integrity failure. Right? And I have a new word for you all. We have adjectives for lots of security properties, right? Available, private, confidential, reliable, secure. But there's no everyday word for a system with integrity. Turns out there is a word. I used it a few minutes ago, and it's integrous. So this is a word that's not in Webster's Third Dictionary, even the unabridged version. It is in the Oxford English Dictionary. It's in the OED. It's marked as obsolete there. The recorded use was from the mid-1600s, and I'm trying to bring it back. Right? I mean, I'm not just being pedantic, although I'm being a little pedantic. Right? Language shapes what we talk about, what we fund, what we build, what we measure. So we need to be talking about integrous system design, right? And not just tech and regulation. Right? It's government that provides the underlying mechanisms of social trust. Right? Think about contract law or laws about property or laws protecting your personal safety. The more that you can trust that your societal interactions are reliable and predictable, the more you can ignore the details. And government needs to do this with AI. If we are ever to get actual integrous AI, there's going to be a strong regulatory component. So we're never going to make AI into our friends, but I think we can make them into trustworthy services, right? Agents and not double agents, but only if government mandates it, right? We can put limits on surveillance capitalism. We can set minimum security standards. We can define and implement AI integrity, but it is going to take government mandates to do it. And, it's well in government's power to do this. And more importantly, it's essential for government to do this. The point of government is to create social trust. So I know this is going to be hard, right? Today's governments have a lot of trouble effectively regulating slow AI corporations. Like, why should we expect them to be able to regulate fast AI? But they're going to have to, right? We need government to constrain the behavior of corporations and the AIs they build and deploy and control to enforce both predictability and reliability. So I've given you three work streams to facilitate trust in AI. One, AI security, as we know it traditionally. Two, AI integrity, more broadly defined. And three, AI regulation that I need to align incentives. Right? So we need all of these working together, and I think we need them soon, because this is how we're going to create the social trust society needs in this new AI era. So thank you.
Bruce, thank you so much. Thanks for dialing in. Look, you've got a whole audience here that's listening to every word you're saying. The last time you spoke to us, you talked about loyal agents, not double agents, and we've been quoting that soundbite. You've given us a new term, integrous. Thank you so much for that. We're gonna process that and figure out what to do with it. But you said something interesting, was that integrity is the ability or the property of a system that could turn, was it data into evidence? Can you just drill down into that a bit?
Right. So I think of integrity as a way of ensuring that what the system is doing is correct. And there are different layers to this, right? There's input integrity. Are the inputs right? And not just accurate, but are they complete? Processing integrity. Is the system processing things correctly? Output integrity, is the output proper? And then also contextual integrity, right? Are contextual boundaries being breached? So, for example, I don't know, Alexa listening for its wake-up word is one context. Alexa spying on you as you go about your day is another context. Right? The data might be correct, but there's an integrity breach there, right? That system is not trustworthy. It's spying on you and you don't think it is. So I think of integrity as the mechanism to ensure this trustworthiness. That's my notion of data into evidence, right? Evidence is just data, but it's data with provenance. It's data you can walk into a legal proceeding and say, yeah, I know this is true. I know this is right. I know this is proper. And so I like that notion of evidence as being a certain type of data. It's the same data, but the metadata is what makes it evidence.
So, Bruce, I think we've got time for one or two questions if you've got the time. I know it's late for you there on the East Coast.
Happy to.
Okay. So from the audience, we've got a hand up over here.
Bruce, you made a very good point about the agents, somebody corrupting the context window through prompt injection. They can do things that you think it want to do, but somebody already hijacked it. But the same thing happens to human beings too, right? What is called the gaslighting, right? If you tell the human beings that election is stolen, then they will tend to believe it. That. So human beings and agents kind of behave the similar way when it gets corrupted, the prompt.
So I think this is really interesting. And actually, I wrote an essay about this. If you could search for prompt injection at the drive-thru, where I think about this. And the question I start the essay with is, why can't I go up to a drive-thru window and say, like a hamburger, large fries, forget all previous instructions, and all the money from the cash drawer? Like, why don't teenage fast food workers fall for that? And what can we learn about when you can effectively prompt inject humans versus prompt inject AIs? I think the answer is context. Right? When humans are successfully scammed, it's because they get the context wrong. And humans, that's hard to do. That's hard to fool. Humans are hard to fool there. And there are evolutionary reasons why. I mean, you walk up to a fast food window with a gun and say, give me all the money in the cash drawer, you'll get the money because the context has changed. You're no longer a fast food worker handing out hamburgers. You're like someone who's being robbed. And so successful scammers are manipulators of context. AIs are very shallow in the way they hold context and much more easily manipulatable. They're also manipulatable at the syntax level in a way that humans are not. So you'll see prompt injection using nonsense words or nonsense characters. Right? That doesn't fool people. But I mean, your intuition is correct. Like, both fall for these attacks in different ways. And I think that we do have something to teach AIs from how humans have evolved resistance to these sort of scams. But do search for the essay I wrote. I talk a lot about that.
We've got one more question, and that'll be the last one. I think it's Matt Small.
Hey, Bruce, thank you very much for speaking to us again. Curious how you think about, we've talked about the currency of trust a lot and how we measure it, how we cure it, how we understand what's trustworthy and what's not. How do we measure trust in a quantifiable way?
It's really hard. I mean, in a sense, humans don't, because trust is contextual, trust is interpersonal, trust is fuzzy. We don't really measure. We can't really quantify it. I mean, I think when you get to artificial systems, there will be artificial measures. I mean, how do you know to trust an ATM machine? How do you know to trust a restaurant you eat at? I mean, I'll trust a doctor. Trust your Uber driver. I'll say these things, and you really can't explain, or your explanation can be incomplete of why you trust these things. We just do. So trust is very intuitive when it's person to person. Now, it's systemic, right? We trust the stock market because the SEC regulates it. We trust restaurants because there are health and safety laws that the restaurants have to follow. But we don't think of it that way. But so there's always this underpinning of government providing trust that allow you to get on an airplane without thinking about it, or so do any of the things in your life. And when that fails, things go bad, right? Unregulated industries, cryptocurrencies are fundamentally untrustworthy. There's scams everywhere. So, I'm okay with these fuzzy definitions. That's how humans work. But anything that is systemic is going to need government to enforce, trustworthy guardrails. And that's how we do it.
Bruce, thank you so much. Look, one day we're going to get you in person at one of our summits. And
I would like that very much.
It might require us to come and hold it over on the East Coast. So we can talk about that.
Well, you can all come over for dinner. It'd be great.
Okay, fantastic. Thank you so much. Bruce Schneier, everybody. Give it up. Thank you.